Hello friends, welcome to the third video on three-phase system MCQ discussion. We will be doing question number 91 to 95 this class. But before that, I had skipped one question in the last session, which was question number 89. I was confused with this statement, any two pair of terminals. Actually, it is any pair of terminals or two pair. Any pair of terminals or two terminals. Okay. So I'll read the question again. Three equal resistance of magnitude 5 ohm each are connected in delta. The resistance between any pair of terminals of delta will be. So 5 ohm is connected in delta manner. Resistance between any pair of terminals. So there are three terminals. Let's choose one among them, one pair. Okay, so I'm choosing this one. This is a pair. So when look from this side, what is the net resistance? They are asking. Okay, so no need of this branch. Every resistance value is 5. So this is actually very simple because 5 and this 5 and this 5 are in series. So 10 in parallel with this 5. Okay. Now what is R net? It is actually a parallel combination of 10 and 10 by 2. So R net will be 10 by 3. Or the direct formula is 10 into 10 by 2 by 10 plus 10 by 2. R1 R2 by R1 plus R2. What is that? 100 by 2 divided by 30 by 2, which is 2 cancel. 100 by 30, which is 10 by 3 again. Okay, so 10 by 3 means option C is your right answer. 89 option C. So moving on to today's set. Question number 91. A three-phase star-connected system is supplied by a line voltage of 440 volt. The value of the current is 50 ampere. What is the power in kilowatts consumed by the system if the current lags the voltage by 45 degree? So it is a star-connected system. The active power equation is root 3 VL IL cos phi or 3 V phase I phase cos phi. Now that you are given with a line voltage, we'll choose this equation. So root 3 into 440 into IL. The current, the line current value. So here in this question, it is just given the current. Usually for the current, they will specify whether it is phase current or line current. But since it is a star connected, let's don't mind that because in star, line current and phase current is going to be equal only. So we will put this 50 for the substitution of IL, and cos phi is cos angle between voltage and current is 45 degree, cos 45 degree. Solving root 3 into 44 into 50. 44 into 5 is, it is 220. 220 carrying these two zeros, and cos 45 means it is 1 by root 2. Okay. Now I will club this root 3 and root 2 to get root of 3 by 2 into 22. This 30 can be put as k. Now what is root of 3 by 2? It is actually root of 1.5 into 22k. Now I will write this as root 15 by 10 into 22k. That is root, I will round it to root 16 divided by root 10 into 22k. Root 16 we know it is 4, and root 10 we know root 9 is 3. So let's approximate this root 10 also to be 3 into 22k. So you will end up as 22 into 4 is 88 by 3k. What is 88 by 3? 88 by 3 is, it's almost around the 27. Okay, so from this options 26.94 is closer to 27. There is another value 24. You can also recheck And you can do it in proper way and find out whether it is 24. Okay, so most appropriate answer is option C. Okay, appropriate answer with what we arrived is option C. Okay, moving on to question number 92. So option A was 91C. Question number, the answer for question number 91 is option C. Now, question number 92. A delta connected three-phase circuit has three resistance of 36 ohms in each phase. What is the value of per phase resistance of the equivalent star connected circuit? So, if every values of a delta connected resistor network is R, then when you make it into a star connected one, every value will become R by 3. This you need to by heart. In reverse case also, you have to multiply it to 3. Okay, if all the resistors in a star network is transformed to delta, then you have to multiply with 3. Okay, if you need to convert to delta, then you have to multiply it with 3. If you have to convert to star, you have to divide it with 3. Okay, and if the resistor values are different like Ra, Rb, Rc and not, for that a particular formula is there. I will put the link for that. I have uploaded some equation for that too in this video, in this channel. So here 36 by 3 means 12. Option A is the right answer for question number 92. Okay, option A. Next question 93. Calculate the power factor of an AC circuit having the impedance of 16 ohms if a 4 ampere current flows through it and its average power consumption is 200 watts. See, I don't know why this question is among this three-phase system, because in this question there is no mention about three-phase. Is there anything about three-phase? No. They have just said it is an AC circuit. Okay. So for that, the power consumption equation is just I square R. They have not mentioned about a three-phase system or RYB or line current, line voltage, anything. They have just said about the power consumption and the current passage is 4 ampere and just simply an AC circuit. Okay, it is titled just an AC circuit. So I square R is the power consumption equation and it is equal to 200. The current value is 4. So from that R is equal to 200 divided by I square. I is 4. So 4 square is 16. So R value is 16 by 4. 550 by 4. 50 by 4 is 12.5. Okay. Now the impedance is also given. Impedance means Z value is 60. Okay, we have to find the power factor. Power factor, we know it is R by Z. Okay, so that is 12.5 divided by 60. Now let's do what is 125 by 16. I think I can reduce it with 4. 16 by 4 is 4. 125 by 4, what is that? 3.41 10 to 1 3.125. Okay, so again 3.125 by 4. So 3125 divided by 4 means it is 7, 28, 32, 8, 5. So 781 something. So putting the decimal, it is 0.781. So 0.781 is the power factor value. 93 option B. 93 option B. Moving to the next question, number 5. 94. Determine the value of the phase current for a balanced delta connected system and the value of line current is 8.7 ampere. So it is a delta connected system. uh, IL is equal to root 3 I phase for a delta connected system. Phase current, we have to find the value of phase current, and line current is 8.7. So 8.7 divided by root 3 is equal to phase current. Now 8.7, you know that 1 by root 3, I have told many times, it is 0.577. Remember, 1 by root 2 is 0.707, 1 by root 4 is 0.5. So among this, the middle number 0.577 is the number to be remembered. So 8.7 into 1 by root 3 is 0.577. Um, where is that? It is about 8 into, see, this is like 8 into 0.5 is around 8 5s are 40, and it is around 4 that is coming, but 4 is missing in this options. So nearest value is 5. So what, let us just multiply and see. 87 into, I will take it as 0.6. Okay, 0.557 is enough. 7 sevens are 49, 8 sevens are 56, 6, 9, 5, 9. Yes, 8.7 and 0.5 in 3 decimals, right? So it is 4.959, which is coming about 5. So option D is your right answer. Yes, 94, option D. Okay, moving on to the last question for the video. Question number 95. A three-phase delta connected system is supplied by a line voltage. It is a delta connected network. Line voltage is 200 volt. The value of phase current IL or IPH is equal to 30 amps. What is the total power consumed by the system if the current lags the voltage by 30 degree? Okay, so it is root 3 VL IL cos phi. So root 3 into 200 into IL is 30 into cos 30 is root 3 by 2. Okay, so no, sorry, here it is a delta system, so I have to make this I current value equations correct. That is, it is given the value of phase current is 30 ampere. So it is phase current which is 30 ampere. So in order to convert it to line current, I have to multiply it with root 3. Root IL is equal to root 3 I phase, which is root 3 into 30. So it's just not 30, I have to multiply it with root 3 also. Okay, so I will club this root 3 and this root 3 to 3. So 3 into 2 into 3 is 6000 into root 3 by 2. So it is 6 by 2 is 3, again 3 into 3 9, 9000 into root 3, or it is 9 root 3 kilowatts. What is 9 root 3? Value of 9 root 3, 1.73 into 9. We know that 1.73 into 10 is 17.3. So that will be, this value will be lesser than 17.3. Let's check among these options. I think every values are less than 17.3, but there are two options, which is option A and option D, are closer to 17.3, isn't it? Okay, we'll do this directly. 9 3 is 7. 63, 65, 9, 9 plus 6, 15.57. Okay, 15.59 is the right answer, 95C. Okay, we'll be coming back with last set of questions. Thank you.